All right, here we are for video 2 for section 5.1. And this time we're going to do a little more algebra-y function equation kind of stuff. So a quadratic function is any function that can be written as f of x equals ax squared plus bx plus c, where a, b, and c are all real numbers and we want a not equal to 0. If a equals 0, we just have a linear function. So we're going to use Desmos to graph this function, and I don't want to chop back and forth, so I just went ahead and put the graph right in here. All right, so the first question I'm going to ask is, what is the value of a? Well, if I look at my equation up here, I can see that my a value is 2. Okay, I can read it right off of here. There's my a value. The coefficient on x squared is equal to 2. And here's a general rule for you. If a is greater than 0, if it's positive, the function will open up like a smiley face. If a is less than 0, the function opens down like a sad face. So that's something you can tell. I'm using the graph to help me, but even if I didn't have the graph, I could look at this function and I could look at my a value and I would know that the function opens up like a smiley face and that my vertex is going to be a local min, right? All right, number 2, how do we find the axis of symmetry? Here's a formula for you. The axis of symmetry for a quadratic function is defined by the equation x equals minus b over 2a. So we're going to algebraically, you mean not by just looking at the graph, algebraically find the axis of symmetry for our example. Well, let's rewrite it. It's f of x equals 2x squared. Oh my gosh, I'm having some zoom in and out problems today. F of x equals 2x squared minus x minus 3. So for our example, how can we algebraically find the axis of symmetry? Well, we want x equal to minus b, which is, in this case, a is 2, b is negative 1, that's what's sitting in front of there, and c is negative 3. So you have to be a little careful when you're picking these out. Sometimes it really helps if you rewrite with all plus negatives instead of subtracts. 2x squared plus minus x plus minus 3. So a is 2, b is negative 1, and c is negative 3. So plugging this into my formula for the axis of symmetry, I get minus b, which is negative 1, over 2a, which is 2. So minus negative 1 is positive 1, 2 times 2 is 4. So my x equals 1/4 is my axis of symmetry. And now I use my graph as a tool to support my algebra, and I can go up and look, and I say, yeah, if I look at this parabola that I graphed on Desmos, and I drew in my axis of symmetry there, it does look like it's happening at x equal to 1/4. All right, so we've decided our parabola opens up algebraically. We can find the axis of symmetry algebraically. The next thing we're going to do is we're going to find the vertex. Now remember, the vertex for a quadratic function always occurs along the axis of symmetry, like we talked about before. We know the x value is already 1/4. So the vertex here is happening at 1/4 is the x value. How do we find the y value? Well, we know the function, right? We know the function is f of x equals, well, maybe we know it, 2x squared minus x minus 3. We know the function is 2x squared minus x minus 3. So if we know the x value, we can find the y value at the vertex by simply plugging in the x value. F of 1/4 equals 2 times 1/4 squared minus 1/4 minus 3. All right, we simplify this to 1/4 times 1/4 is 1/16 minus 1/4 minus 3. All right, this is 2/16, which is the same as an eighth. And now we just need to get some common denominators. 1/8 minus times 2 times 2, 2/8 minus, let's see, times 8 over 8 is minus 24/8. 1/8 minus 2/8 is minus 1/8, minus 24/8 is minus 25/8, which I think is minus 3 1/8. And I think that's the same as minus 3.125 if you like decimals. All right, so that looks just about right to me. So 1/4, not a question mark anymore, minus 3 1/8. And there's my vertex. So how did I find that again? Well, I remembered the vertex always occurs along the axis of symmetry. I used my minus b over 2a formula for my axis of symmetry, and I got a fourth. To find the y value of the vertex, I simply plugged in 1/4 into my function to find the output at ax equal to 1/4. All right, so we're rolling along now. We found the maximum or min value. We found if it's a max or min. We found the vertex. We found the axis of symmetry. Let's find the vertical intercept. Well, in this one, you can kind of read it right off. I think it's going to be at -3. If the function is in general form, that is ax squared plus bx plus c, the vertical intercept is always going to be at c. And that is because if you look at this, f of x equals ax squared plus bx plus c. If you plugged in f of 0 to that, this would be 0, this would be 0, and all that would be left would be equal to c. If your function is not in general form, it's okay. You're still just going to plug in x equal to 0. The vertical intercept is always going to happen when x equals 0. So we can always find the vertical intercept by finding the function value at 0. So using our function, I can just peek at it up here. It's 2 times 0 squared minus 0 minus 3, which is -3. So my vertical intercept is over 0 down 3. All right, so now one more thing we need to work on, and that is our horizontal intercepts. Horizontal intercepts are the points where the quadratic function lies on the horizontal axis. Be careful, not all of them have horizontal intercepts, and we'll talk more about that in a bit, but let's look at this one that does. We can almost read them off. It looks like it might be -1 and 3/2, or 1.5. But one way to use this for sure is to use the quadratic formula. Now, I'm not going to spend a lot of time in this class on the quadratic formula because it really is something you should have seen in a previous class. However, if you are rusty on it, which a lot of people are, please, there will be links to videos of all about refreshers on the quadratic formula. So if you need a refresher, go watch those videos. And I'm going to do an example right here, and I'm going to do another one later. So let's algebraically find the horizontal intercepts for our function. So remember, the horizontal intercepts are where the output equals to 0. So we're going to set 0 equal to, I always keep getting the function, 2x squared minus x minus 3. 2x squared minus x minus 3. And I'm going to use the quadratic formula to solve this. Now, if you're a great factorer, great, go ahead and factor. You totally could factor this. If you're not great at factoring, quadratic formula always works. So let's go ahead and plug this in. Remember, a is 2, b is -1, c is -3. All right, let's plug this in. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. All right, we got to simplify this guy. -1 is 1, plus or minus the square root. 1 squared is 1, minus 4 times 2 is -8. Minus 8 times 3 is -24. So this is 1 minus 24 or 1 plus 24. 1 minus -24 or 1 plus 24 all over 4. So that's x equal to 1 plus or minus the square root of 25 over 4. Please feel free to use a calculator to help you with the computations. So that's 1 plus or minus 5 over 4. Let's break this into our two cases. 1 plus 5 over 4 is 6 over 4, which is 1.5. Or 1 minus 5 over 4, which is -4 over 4, which is -1. All right, so we've got two values for x. X equals 1.5 or x equals -1. And again, I just used a straightforward application of the quadratic formula. If you're rusty on that, please do go watch the videos on refreshing on the quadratic formula. And actually, this really verifies with what I see on my graph. I see x equal to 1.5 here and x equal to -1 there. So that works great. All right. So we went through and we found all these different things algebraically for a function. And now I'm going to give you guys another practice problem. So what I would like you to do is pause this video right now and go through and answer all these questions without using Desmos, without graphing. Just try to do it all algebraically, and then we're going to go through and we're going to check our answers together. All right, I hope you're back from doing the practice problem. Let's do this one together. Does this graph open up or open down? Well, A, also looking at the parameter A, is -3, which is less than 0, so this guy opens down. Sometimes it helps me to draw a little picture, and so I know that's going to be a local max. All right, B, find the axis of symmetry. X equals minus B over 2A is my formula for the axis of symmetry. So I know A is -3. I can look up and see B is equal to 4. So my axis of symmetry is going to be X equals -4 over 2 times -3, which is -4 over -6, which is 2/3. X equals 2/3 is my axis of symmetry. Here's a time when you can't use decimals. X is not equal to 0.6. Boo, it's not. It's 0.6 repeating. I guess you could write down X equals 0.6 repeating if you want to. All right, we found my axis of symmetry. I'm going to use 2/3 though. Find the vertex. Well, I know the vertex always occurs at the X value of the axis of symmetry. So I'm going to find G of my X value, which is 2/3. -3 times 2/3 squared plus 4 times 2/3 minus 1. Plug this guy in. -3 2/3 squared is 4/9 plus 8/3 minus 1. All right, so that's -12/9 plus 8/3 minus 1. If you guys are doing this on a calculator, that's fine. I'm just doing this the slow way. So this reduces actually. 3 goes into both of those. That's -4/3 plus 8/3 minus 3/3 if I want to get a common denominator there. So how many thirds is that going to be? -4 plus 8 is 4. 4 minus 3 is 1, 1/3. So my vertex is at 2/3, 1/3. All right, check, check, check. Find the vertical intercept. Number D. G of 0 will give me the vertical intercept because I'm neither left nor right. I'm at x equal to 0 when I'm crossing the y-axis. G of 0 is -3 times 0 squared plus 4 times 0 plus, minus 1. So my vertical intercept is equal to -1, so it's the point over 0, down 1. Check. And finally, find my horizontal intercepts. All right, that requires an application of the quadratic formula. I'm going to solve 0 equals -3x squared plus 4x minus 1. I'm going to solve this using the quadratic formula. And if you don't know the song, maybe you should memorize it, but it's x equals, I'm not going to sing it, -b, so b is 4, plus or minus the square root of b squared minus 4ac all over 2a. Minus 4 plus or minus the square root, and 16 is 4 squared, minus 4 times -3 is -12. -12 times -1 is +12, all over -6. Minus 4 plus or minus the square root of 4 over -6 equals -4 plus or minus 2 over -6. So break this into my two cases, -4 plus 2 over -6 and -4 minus 2 over -6. -4 plus 2 is -2 over -6 is 1/3. -4 minus 2 is -6 over -6, which is +1. So my x-intercepts are 1/3, 0, and 1, 0. All right, so you could go ahead and graph this on Desmos and look at the graph. We found all these pieces algebraically.